NASA scientists are one step closer to unlocking the secrets of the universe. The James Webb Space Telescope completed its final deployment sequence just yesterday.
Yeah, and now more than 2 weeks after launching from South America, the Webb telescope's closer to transmitting images back to Earth and allowing researchers to study the first stars and galaxies in our universe. Janet Ivey is with us. She's the president of Explore Mars, Inc. Janet, it's so good to have you here. We understand that, this is the most powerful of telescopes ever, and it is now, fortunately this morning, it's fully deployed, as I understand it. But the next couple of weeks are going to be pretty critical because it's still traveling.
It's still traveling. Thank you, Christy and Boris. It's great to be here with you. We are celebrating. So let's just go over this. 50 major deployments are complete. I mean, this thing, everything had to work perfectly, and it has. That's what makes this whole thing even more amazing. 178 release mechanisms were properly released. Yesterday, they were down to the last 4 to get that final wing of the mirror. And after that was deployed successfully, then they spent hours latching it in place. 20 plus years of work realized. And so the James Webb is about 600,000 miles towards its target at L2. And people always ask me, what exactly is Lagrange point 2? It's this beautiful accident of orbital mechanics and gravity between the sun and the Earth, where if you put anything right there at L2, it's going to stay at this fixed point. And so now in the next 2 weeks, as it gets to this place about 1 million miles away from Earth, you're going to see all of the engineers are going to be working really hard to see these 18 honeycombs get to be this one mirror. And it will take the next 5 months for them to really get all of those 126 actuators in total to have all of these individual mirrors act as one. So we're going to see back to that beginning let there be light moment, and it's going to be something. We don't even know exactly what yet, but get this, it's 100 times more powerful than the Hubble telescope. And so we're going to be able to see those kind of first galaxies and stars that formed, and I think we're going to all have an amazing aha moment, and perchance even maybe it's going to either answer some of our biggest cosmic questions or even add more to our cosmic questions.
That's right, Janet. I love the enthusiasm, the model, the background, and the way that you explain it. I've heard this telescope described as a sort of time machine because it allows us to look back at the way that light and the material in space sort of unfolded into how it is today. How's that possible?
Well, this is the incredible ingenuity of the James Webb. So it is using infrared energy and infrared technology. And so when we have infrared waves have longer wavelengths than visible light. And so when you're using infrared, think about it going deeper and further, almost like an X-ray, right? It's going to be able to see through these dense regions of gas and dust. And that kind of infrared energy is going to reveal objects we've never been able to see. One of the reasons the sun shield had to deploy, it's from the sun shield side to the cold side, there's about a 600-degree differential. And these infrared instruments have to have it cold, super cold. We're talking nearly minus 200 degrees. And that is because it's even after the Webb gets in place in a couple of weeks, it's going to take a while for it to cool down. Again, we're going to be able to, because it's so cold, get rid of any kind of background noise, and so that those images will be pristine and what we will be seeing will be truly stellar.
Very nice, truly stellar. I love it. Janet Ivey, it is so good to have you here. We always appreciate you. Thank you.
Thanks so much,
thank you guys, and anybody can make their own model if they want to. Just go on.